Hi, today we're going to talk about how to draw a square when we're asked to draw a square that doesn't have really nice numbers for side lengths. So in this case, we have to draw a square with side lengths of the square root of 80. Now, generally, when we're asked to do this, we are given a grid or a coordinate plane or some kind of graph system, and then we can draw on that graph. So if it just said with side lengths of 80, that's ginormous, but all we do is count 80 across, 80 down, 80 across, 80 down, and boom, you have a square side lengths of 80. The problem is that if you are asked to do the square root of 80, well, square root of 80 is a repeating decimal that goes, or not repeating, is a non-repeating decimal that goes on and on and on. It's 8.944279191, and it keeps on going. So how in the world can we draw exactly that far over and exactly that far down? We can't. So I'm going to show you a different way to draw a square with the side lengths of the square root of 80. First thing is we're going to need to remember Pythagorean theorem, which is a squared plus b squared equals c squared. So we're going to say that the hypotenuse is the square root of 80. So a squared plus b squared equals c is the square root of 80, and it has to be squared. Now, fun fact, squared and square root, those cancel each other out. So really, square root of 80 squared is just 80. I'm just going to write 80. Okay, now there's honestly multiple ways you could do this. My favorite way is guess and check. We need to find two numbers that when we plug in A and we plug in B, they equal 80 for our square root. So, for example, let's try 5 squared plus 6 squared. And we can just type in our calculator. 5 squared plus 6 squared equals 61. Not what I'm looking for. Let's try another one. 7 squared plus 5 squared, right? So I kept the 5 squared and I just went up 1. The 6 went up to a 7. That is 74 squared. Okay, pretty good. How about I go up again, 5 squared plus 8 squared. So 5 squared plus 8 squared. Okay, well now that equals 89. So now that's too big. So I know it's somewhere in between these two. And I increased the 7 to an 8, and 5 stayed the same. So let's try changing the 5. If this is too big, let's try going down to like 4 squared plus 8 squared. So 4 squared plus 8 squared equals 80, just like we want. Okay, that strategy is called guess and check, and sometimes it's just a great strategy. So now we know that our sides, we're going to have a triangle right here. If I have this triangle, this side is 4 and this side is 8. This side is the square root of 80. Now let me show you how to draw this square. So, oops, I meant to click next. So what we're going to do is, my triangle was 8 by 4. Boom, here's a triangle. Now, okay, I'm not on a grid, so when I show this to you, it's not going to look perfect. If I was doing this on a grid, it actually would be. I've done the 8, so now I have to use the other side to create a new triangle. Well, I did 8 already, so this one's going to be 4, and the other side has to be 8. Okay, boom. Well, same thing here. I used an 8, so I got to use a 4. Over here, 8. And boom. And I used an 8 here, so I got to use a 4. And I got to use an 8. And boom. This is now a square where this side is the square root of 80, this side is the square root of 80, and so on. These are all the square root of 80. So this is something you could draw on a grid, and really that wasn't too difficult. We started with one triangle, and then when I knew this was the side 8, I just had to choose the other side 4 to build my next triangle. And if this is 4, this one's 8, and if that's 8, that's 4, and then 8, 4, 8, 4. And the thing that's inside is our perfect triangle, or sorry, our perfect square with side length square root of 80. Now, even like we could go a step farther. Honestly, I would be done there. That would be it for me. But depending on what the question's asked, we could even go one step farther and erase all of this. Because again, we're on a grid, so the lengths are still staying the same. I'm not like magically changing the lengths. We could erase it and call it like this. Honestly, I wouldn't do that. I like everything there. But there you go. That is creating a square when the side lengths are not really nice sides. Thanks, bye.